Good afternoon, everyone, and welcome to the Oxford Martin School. My name is Carl Frey, and I'm Associate Professor of AI and Work and Director of Future Work here at the school. And it's my great pleasure today to introduce you to Georgios Petropoulos, who's an Assistant Professor of Data Science and Operations at UCS, Marshall School of Business, and is also a Digital Fellow at Stanford's Digital Economy Lab. Before moving to California, Georgios spent 6 years in Brussels as a resident fellow at the think tank Bruegel, where he advised on evidence-based policy regarding platform regulation and the future in work, which informed both policy in the EU and OECD discussions. In his research, he's mainly focused on how to regulate the platform economy, what the accumulation of big data means for competition, and how artificial intelligence and robotics will impact wages and productivity. To answer some of these questions, he draws upon a wide-ranging background spanning a bachelor in physics, degrees in mathematical economics and econometrics, and a PhD in economics, and his work has appeared in numerous journals and policy papers. Today, he will explore artificial intelligence bottlenecks, how we can achieve a brighter economic future, something that we do urgently need. Georgios will speak for around 45 minutes, and then we will open up the floor for questions. Let me remind you that this session is being filmed, so if you do not want to appear on screen, then please do not ask a question. And please do join me in giving a really warm welcome to Georgios. It's a great pleasure to have you. Thank you.
Hello, everyone. Thanks so much, Professor Carl Benedict Frey, for this kind introduction. I mean, as you mentioned, I have been working also both in academics and policy issues, and your research work has been of profound influence for policy and academic development. So it's a great pleasure to share the same stage, and I'm a big fan of your work. I'm going to talk about artificial intelligence bottlenecks and how we can achieve a brighter economic future. And what do we mean by brighter future has to do about enabling new technologies that they are remarkable, and they can can bring us a lot of benefits in terms and efficiencies in terms of production to help us improve economic growth, which is shared evenly across all the citizens of our society. And the first question to ask is, did we achieve that? Well, we have achieved it certainly in the past. The AI revolution is included in the so-called fourth industrial revolution. Before that, we had the Industrial Revolution, the first one that was based on steam engine, the second one which mainly based on electricity, and the third one coming later in 1980s on computers and information technologies. And a common characteristic of all these technologies had to do with being general purpose technologies, meaning technologies that have a widespread and transformative impact on society and the economy. They tend to be disruptive and create new industries and can lead to major changes in the way people live and work. AI, the question is, if AI is another general purpose technology, it is another technology that it has a great transformative impact, that we believe that it will bring great benefits for society, for economy, but so far we haven't seen these benefits in statistics. Of course, this is not the first time. Even from the third industrial revolution and the information technologies, we had these voices that asking the question, what is going on? You can see the computer aids everywhere, but not in productivity statistics. And indeed, if we see the total factor productivity annual growth rate of major economies like the United States or the United Kingdom, we see that there was a phenomenal growth after the Second World War, but especially in the United States and the Euro area. But after the introduction of computers and information technologies after 1980, we haven't seen so much growth, with a small exception of the US between with the United States between 95 and 2000. That was not a prolonged period. And if we restrict our attention to more recent years, we see that we have some fluctuations of focusing on labor productivity in the US. We have some fluctuations, but certainly it was not what we expected from these technologies as we move forward in terms of productivity growth. And don't misunderstand this steep increase here. This is because of COVID that the production paradigm changed, and therefore we need to see in the long run how productivity behaves in order to make any conclusions. So especially if we focus at the systematic use of AI, we could say that after 2009, 2010, we started, AI has been implemented in production function of corporations and in our economy. Instead of seeing an increase in AI in the productivity growth, labor productivity growth, we have seen instead a decline. And we stopped just before the COVID for the reason I just mentioned before. So from 2011, a 3.4% productivity growth, labor productivity growth in the US, we end up in 2019, 1.7%. So what is going on here? If these technologies are so helpful, why we don't see the productivity benefits out of that? Or we have been techno-optimistic and these technologies will never deliver. So certainly there are many explanations, and you choose the one that it is the most convincing for you. The one is certainly that we had false hopes. This will never work. AI is not such a big thing, even if the media and everyone is crazy about that nowadays. And it will not have any major impact in economic terms, in bringing economic growth, productivity, in improving our economic output. But there are also some other explanations that deserve some attention. The one is the mismeasurement. The AI relies on digital economy, and digital economy relies on intangible capital, which is hard to be captured by official statistics. So it could be that there is indeed some growth, but it is hard to measure it. And another dimension has to do with the source of concentration. As we move forward, studies have shown that markets become much more concentrated. So the benefits of AI are only enjoyed by a handful of big corporations, and they are not distributed in a more even way across society, across people, across individuals, across the economy. And another explanation has to do with the fact that in the past industrial revolutions, the growth, the economic growth, the productivity growth didn't immediately arise after the introduction of these technologies, but it took some time to arrive. So I don't believe that these explanations are mutually exclusive, but I have certainly my personal views on them, on which I will base this talk, and which give rise to some bottlenecks that need to be addressed in terms of AI in order to be able to enjoy higher economic growth and productivity and more benefits from AI technologies. And starting with the false hopes do not get so much support from firm-level evidence. Firm-level evidence show that corporations that correctly implement AI in their business, and also some related technologies like robotic systems, they see a great benefit out of that, a significant benefit. They see their business to grow, they see a greater market share, they see greater profitability. And that, I think, brings us to the following question. Why in the firm level we observe this benefit, but economic-wide level we don't? And I think this is the real question to ask. So, of course, if we are talking about mismeasurement, we can talk about a wide variety of digital services that we every day use, but it is very hard to capture in productivity statistics. And there is a new research based on large-scale online experiments, which derive the value individuals get out of consuming these services, even if they don't pay any price for them. Most of them, you need to subscribe and you use it for free. So to use the search engine has an annual valuation, and this is the median number, of more than $17K US dollars. And this is a significant amount. We can look at different digital services and digital goods that there is no positive price and get some valuation out of that. This is very hard to capture in productivity statistics. But again, the problem is bigger than that. It's not only in mismeasurement. It has to do with the fact, first of all, which is consistent with the previous industrial revolutions, and this is called productivity J-curve, that when we introduce a new general purpose technology, which is a breakthrough, it's an amazing technology, super efficient, this is not sufficient to advance the economy and arrive to a new equilibrium with better productivity and production efficiency. You need to invest on complementary assets to develop new business models. You need to develop appropriate skills and other types of touchable capital, which in combination with the general purpose technology will lead to economic growth, will lead to productivity. So, and that takes time. And it took time when we were discussing about the steam engine or the electricity in the first industrial revolutions. So it's not surprised to say that we'll need some time for this to arrive also now. And probably the COVID shock accelerated a little bit the realization that we need new business models that go through the digital channel in order to achieve that. Of course, there is another crucial element for moving from firm level to economic-wide benefits. And that has to do with AI adoption. The annual business survey, which focuses for the periods 2016-2018, it is one of the most comprehensive surveys on the adoption of AI by some prominent researchers, has shown that the share of firms that use artificial intelligence technologies in the US is only 3.2%. So having such a low adoption rate, these companies see the benefits of AI, but it's hard to get the benefits of AI in economic-wide scale. Of course, now you will ask me, if those AI technologies are so remarkably efficient, why more firms do not adopt them? And I guess this is basically the central theme of my talk, to present some of the bottlenecks that prevent the wide diffusion of AI. And these bottlenecks can be divided in concentration in the input markets. What are the vital input spheres? Data, which is very important for corporations that use AI algorithms. Data is the input in these algorithms in order to produce some output, but also the AI skills, how to design the algorithms, how we'll make them effective, how we'll correct their behavior, how we'll implement them in line with the production model of the company, the AI skilled workers work, is also another important dimension. Of course, we have more traditional elements, economic elements, like investing in computing power and infrastructure that can be costly, and that requires some incentives for corporations to do that, and that requires also some policy actions to this dimension. And we have also the concentration in the output markets, the product market competition or the service market competition, which might be a barrier in the sense that if I know that my competitor is a dominant firm in the product market, I know that even if I invest on AI to improve my offerings, it's very hard to compete with that dominant player. And all these are valid bottlenecks that need to be analyzed, and policy conclusions need to be drawn out of this analysis. For the purpose of this presentation, and given the time I have today, I prefer to focus on AI skills and data. But of course, if you have any questions that go to other dimensions, I will be happy to discuss with you later. So let's go to the concentration of AI skills. And this is a work based with in my research collaboration with Wang Jin and Sebastian Steffen. So the concern here is that top firms, by snapping up frontier talent, prevent other firms, especially startups and small firms, from realizing the importance of these skills for their growth. And the adoption of frontier AI skills, frontier IT skills as we call them, it's something that brings also a learning curve. You learn by doing. By adopting more AI and ML skills, machine learning skills, you gradually learn how to integrate them into your business structures and make your business more productive. So it's not something that happens from one day to the other. There is a learning curve that on which your high-skilled workers need to spend some time in order to learn how to do that. So if the AI talent is concentrated towards a handful of corporations, then it is very hard for the smaller firms to get access to the skills that are necessary for develop new AI solutions. And in fact, if we look at reports, we see that this AI skill shortage, as it's called, it has become, as we move forward, an important dimension and an important problem. So what we did is we look at job postings from Lightcast data. And for the US economy from 2010 to 2020. And we identified in the job posting by seeing the description of the job postings if AI skills are included. And we also identified who posted this posting, this job. And then we rank all the employers of the US economy in the number of job postings that include AI skills. So we have a top 10 employers in terms of number of job postings that post about AI skills, 50, 100, and so on. So what is remarkable is then is that we derived the fact that 26.5% of job postings that include AI skills come from the top 10 employers. So there is really a concentration on AI skills. It is the top firms that ask for the majority of the skills, and they can benefit from them. If we look at the other IT, which is the conventional information technology, then this number is 6.9%, it's much smaller. So if we focus on frontier technologies, and we have many here, and in particular on artificial intelligence, we see some higher concentration than conventional IT skills. And this is a point of concern if we want to arrive to an economy which is not only a handful of corporations that invest and take the benefit of AI, but the AI technologies are widely diffused in the economy in order to arrive to a better economic growth point. So if you want, the J-curve, which is basically it takes time, has two phases. The one phase is the one that you build complementary assets for which you need the AI skills. And the second is the boom phase that you see the real benefits of AI to arrive. If we don't solve this concentration of skill problems, this AI skill problem, it will take naturally a much longer period to arrive to the boom phase and see the real economic and social benefits of AI. We need to solve this concentration, solving this concentration issue. This boom phase can arrive earlier. This is basically the point. If we want to arrive, solving this AI skill bottleneck is of high importance in order to arrive to a future of greater economic value. And just talking about skills and what big firms do or how they acquire, one strategy they employ to acquire the skills is through mergers and acquisition strategies. So in this project with Jeffrey Parker and Marshall Van Alstyne, we collected data on big tech, Google, Facebook or Meta, Amazon, Apple, and Microsoft. And what we were interested here is to see when they acquire a company, do they acquire the technology, do they acquire the talent, or both? So if the data is from the inception of these companies until early 2020, and what we found is that the most of these corporations acquire talent at more than 80% of their merger and acquisitions they are involved, especially Google, Meta, Facebook, Apple. Amazon has a little bit more, less percentage of talent acquisition, but more 60%. And Microsoft is the firm that focuses more on technology. So still it has a higher than 50% acquisition, number of acquisition, talent acquisitions of more than 50% of its total acquisitions. But because it focuses on technology, this statistic is smaller. Facebook is a champion because many times it acquires companies just for the talent without being interested for technology. And this is another signal to realize that these corporations are looking actively for AI talent, and this is an important dimension for their operation and their success in the market. Now, of course, how we can approach this issue, how we can solve it. And here are some thoughts based on some data we had collected with Sibrat Breckelmans. We focus on high skills and how we'll make societies more skilled. High skills are also, the AI skills are included in high skill workforce, right? It's high skills that you need to develop. And what we looked is how we can ensure that our workforce have higher skills and how this is related with some other policies and market characteristics we have in mind. And I will present two graphs here from this line of research. The one is we have this upskilling index. So we go to, this is a country level analysis. We go for each country and we see the share of workers that work in high skill jobs, middle skill jobs, and low skill jobs. And we create this upskilling index that takes value from -1, which means all people are in low skill jobs, to 1 that we have all the workforce is high skill workers. And then we plot the different European countries. This is exercise from 2016. So I include UK and I say that it is basically EU. The first important dimension is the labor market flexibility, which is a composite index based on an executive opinion survey. So it's a survey data, which includes, for example, measures of cooperation in labor-employer relations, flexibility of wage determinations, capacity to retain talent, quantitative measures. You can see the reference here, the Schwab and Salam Martin paper from which we borrow this index for further details. So if we look more carefully, first of all, UK is a frontier in terms of labor market flexibility. But what is important here is that we see more or less a positive association, correlation between the upskilling index and the labor market flexibility. So having more flexible labor markets, it's also something that it is associated of employing higher skilled workers, which could be relevant if we are talking about bringing wide benefits from new technologies, since the high skills are more relevant to them. And the other dimension is education. So what we did is we used the same upskilling index in 2016, and then we used in the x-axis the PISA 2015 science score. It's a measure ranging from 0 to 1,000 based on micro data of the OECD PISA test. So what is this test about? It's a standard test administered at a regular period. It is repeated every few years to 15-year-old high school students across the countries that are participating in the program. And then we see we have a clear outlier that it is Finland. We have Estonia that behaves well. UK has also a very good performance. But the important thing to see here is that the upskilling of society and the PISA score are also positively correlated. And PISA score is an imperfect measure of education, so education can be an important parameter more generally, and especially if we go beyond high school, universities that can bring some upskilling of society, which is relevant here in order to ensure the diffusion of technologies that require high skills to be relevant, that are relevant to them, and work with them in order to get economic benefits. But of course, we need also to keep, when we are talking about skills, we also need to keep our attention to some other dimensions. The one is that it is not that you build your skills in education. You get your skills, you go to the job market, you get a high pay, and that is the end of the story. I mean, this interesting paper by Demick and Noure basically point towards declining returns of skills for computer science and engineering jobs. Let's focus on the upper curve here. This upper curve basically it's people with engineering or computer science major that found an engineering or computer science job. And we see here how the wage evolves over time. We see declining returns over the wage because their skills may be relevant today, but may not be relevant tomorrow, especially in jobs that they are focusing on new technologies and how they are deployed. I will give you an example. If you were asking a computer scientist which is the most relevant programming language for finding a good job in 2006 and 2007, probably the response would have been C++. Asking the same question in 2018, it's hard not to say Python. So as the skills evolve, if people stay stuck on the skills they acquire through their education, then they will see the returns in the market to be declined, because the relevant skills, as the technology progresses, the relevant mix of skills also changes. And this is something we need to keep in mind. It's not just we have good education and this is over. We need something more here if we want to keep skills relevant, high, and interacting with technology to give high productivity benefits. And the other point I would like to mention, and this is something I haven't seen so much research. If you are working on that stuff, I would welcome to see some research from you, is that AI can also raise entry barriers. And let me basically focus on the task-based approach, which is something used nowadays to determine the implications of AI and new technologies on the future of work. What this approach says is that each occupation is basically a continuum of tasks, different tasks. Some of these tasks are done by machines, some other tasks are done by workers. So how AI affects this bundle? The AI affects this bundle, first of all, by expanding the set of tasks that can be done by machines. As AI makes machines more clever, more capable, it is natural to allocate to them more tasks. But On the other side, we have also some productivity and new task effects. If workers are capable and interact with AI, they become also more efficient in their tasks they provide. So there is a productivity effect on the tasks done by workers, which means that they can keep the competitive advantage against machines, but also some new opportunities, new tasks that arise in occupation. So the definition of occupation may also change a little bit because of technology, because of the new tasks can be done by workers that they could not do before the AI era or any technological breakthrough era. So why I'm mentioning this? Because on the one side we have displacement, on the other we have augmentation, productivity and new productivity and expansion of tasks done by labor markets. I think an important dimension is to realize for which kind of workers in the same occupation is this augmentation effect more relevant, and for which category of workers in this occupation it is a displacement more relevant. Imagine a lawyer. A lawyer can benefit a lot by having an AI assistant, preparing the documents, the defense strategy, but of course it's always the lawyer that should go to the court and be passionate about defending their clients, right? It's hard to imagine the AI system doing that. Even if it has the capacity, you need this personal interaction, personal speech, change of facial expressions, the passion, which is important when you defend your clients. But imagine now a young lawyer that wants to be hired by a law firm, or that experienced lawyer that goes to the court and be passionate, in order to prepare the contracts, the defense strategy of the experienced lawyer. Since the experienced lawyer now can use AI in order to be more productive in these human-oriented tasks, it may be less inclined to hire a young intern in order to help him and assist him with preparing the defense strategy. So AI can raise the entry barriers in occupations. It is the inexperienced people that are hired to do some very basic tasks, the ones that probably will be negatively affected by these systems. Now, how this intern will gain experience and will become the next generation of experienced lawyer if he does not do the internship first? So that creates, in a dynamic sense, an issue which requires some solution. So getting occupations fixed, getting tasks fixed, and studying only how AI affects tasks and occupation is not enough. We need also to follow workers across their career, see what the tasks they do in the beginning of their career in this occupation, what are their tasks they are doing after they evolve and become more experienced, and see how the differential impact of AI across all these different categories. And this is something I believe it's very important to do as we move forward in order to assess how important are these entry barriers. It's entry barriers to enter to the occupation, given that by entering, I do only a subset of tasks of these occupations because I don't have the experience to do more. And probably AI will be crucial there. So, having mentioned all these concerns on the AI skills and concentration issues, let's talk briefly, and I will be generic, I would love to hear your views here, about policy actions. And certainly, each country has its own AI strategy in place. What I would refer here is, first of all, education, curriculum modernization, integrate AI, data science, and computer science into education, develop standardized AI literacy programs. On higher education, support the programs and research centers that they are with AI-focused degrees, as many schools started doing already. Encourage interdisciplinary programs that combine AI with fields, especially in healthcare, law, agriculture. And given the declining returns of skills, also promote lifelong learning initiatives, either by providing more incentives to employers to offer these opportunities, or for smaller corporations to create a platform of coordination that they can jointly offer these opportunities to their workers. And that can also lead to workforce upskilling and reskilling. We need to bring public and private partnership into the game. And the incentives for employers is also the key, and it is something that requires some state intervention for these incentives to be offered. And on the top of that, for the talent attraction and retention, immigration policies are key, especially for high-skilled individuals. Recently, that has been under debate in some jurisdictions. Immigration research has shown that high-skilled individuals that immigrate to more developed economies, they can contribute to economic growth of these economies, and there are many success stories. So streamlining visa and residency processes for AI professionals and researchers, create AI talent visas maybe, or fast-track immigration pathways could be avenues to explore if we want to attract more talent given the AI shortages we observe. And on retention incentives, we offer the offering of research grants, innovation funding, some R&D incentives, tax credits, foster AI clusters with quality of life benefits to retain professionals locally, could be other avenues that should be further explored in order to solve these AI skill issues we have. And that is the first, let's say, bottleneck that I wanted to analyze, and happy to discuss further. There is another one that refers to data. And data bottleneck is the one, data, first of all, plays a central role in digital economy and in AI ecosystems. We have firms that collect, analyze data, get to know the user preferences out of this data, and provide more efficiency products and services. And the value creation in algorithmic systems used by AI follow the following steps. The first one is data collection. Collect raw personal and non-personal data that it is relevant to the scope of the algorithm, to what this company wants to do with this algorithm. The second is to structure this data into appropriate formats for further feature engineering and analysis. This is where AI skills would be very helpful. This is the domain. So data and AI skills are clearly interacting with each other. And then the other relevant is to analyze the data using data analytics techniques. AI skills are also relevant here. To train AI models and to produce high quality outputs. I mean, the traditional AI systems had to overall perform two kinds of tasks, classification and prediction. So basically, that requires some model training to be able to have a better classification and prediction. One example of AI classification exercise is in banks that use AI in order to give loans. The AI should classify to whom this loan will go, and they do that by predicting what is the probability that this individual will receive the loan, will repay it before the maturity rate, right? And then we have the model improvement. That means that the company should have some clear metrics based on which they evaluate the AI model output and they see how well it behaves. And if it does not behave so well, then they rerun all this loop by changing some of the parameters, a weighting function in which data is weighted in the algorithmic system, right? So this is mostly the case for supervised machine learning, for example. But you need this interaction between data and AI skills in order to produce good quality algorithms. So it's not only AI skills, it's not only data. And let me give you the following example. We have firms A and B. A offers a better, more valuable service, has access to more data. B is behind. And the value of data, the value of your service that depends on data follows the following positive data feedback loop. Better information, more and greater variety of high quality data leads to better products and services, but also help my algorithm, my AI algorithm, to be trained with higher quality input and perform much better. So the weights between A and B increases over time if A constantly has access to more data and higher quality data because of AI systems. Now, this is great news for AI, for A, but what is the problem here? Recall, the problem is the diffusion of AI technologies. How B will be convinced to invest on AI if lacks the data in order to compete with firm A more efficiently, right? So how we can induce B to be more active in the AI investments and improve also its services if we have these weights in data collection and analysis. And so this is recognized by regulation. And for very big platforms, the European Union has already enforced the Digital Markets Act, which obliges gatekeeper to provide end users and third parties, business users, with the right to move their data wherever they want. So they try to put their data, to put the control over the data from the platform or the firm that has access to data to individuals and to business users that can use their data in another firm. So moving their data from A to firm B. And this does not seem to work so well, this data portability right, because especially if we talk about platforms, the data is co-generated. I interact with other users in the platform and I create an interaction point, which is my data. This is my data, is data of the other side. I clearly cannot take that data interaction data I see, it's only my point. Let me give you an example from social media platforms. We have two good friends, Sami and Kat. Sami posts in a social media platform A, which is a coffee place. Coffee place A is my favorite place for afternoon tea. I hope you like afternoon tea, right? And then Kat responds to this message in the same social media platform. I fully agree. I love that place. Now, Kat considers to move her data outside the platform. Can she move this interaction data point that reveals her preferences, that she likes afternoon coffee and she likes that particular place? The answer is no, because this data set involves also personal data of Sami. So Kat cannot take Sami's data and move it away in another platform. So the platform where this data generated can take the full view of this data interaction and can get unique insights for Sami and Kat. In order, for example, to offer them more personalized advertisements and monetize their business out of that. But it is very hard for this interaction data to be moved with a data portability right to another firm or another platform in the economy in order to have more information and more incentives to invest on AI and AI skills. So we come forward with a new solution with Marcel van Alstyne, Jeffrey Parker, and Bertie Martens, which we call it in situ data rights. And basically what we say here, I will give only the main logic and happy to evolve. The piece is out, you can read it if you want, is we don't have to move the data outside the platform. We just, for Kat, it would be sufficient to invite another digital firm with which she wants to share her data to bring the algorithm in the platform where this interaction data is located. And then it is much easier to protect Sami's privacy, who never authorized for her data to be visible to that other third-party firm. And that could be an avenue to explore on improving data portability and bring real control of data to the users of these systems, so that we have more symmetric data flow across all the ecosystem. Each one chooses with whom will share data and gets benefit out of that, as a consumer, I will only share my data if the other firm gives me some benefits. And in this way, we have more symmetric information and more incentives for the other firms to invest more on AI in order to get a competitive advantage. Generative AI is also a game changer, and I will close with that. We discussed about AI for classification and prediction tasks with the bank example and the loans. But generative AI does something completely different. It generates data. Text generation, ChatGPT, image generation, music and audio generation, video generation, data augmentation and simulation. And that gives a rise to a new data set, the synthetic data revolution. And this data is created by generative AI systems based on reality. And the prediction by Gartner is even if today these data sets are not used so extensively, by 2030, it will be the synthetic data that will be the majority of data that is relevant for AI system and will be used extensively by AI algorithms in order to perform their operations. So this is a new development. It's the future of AI, and it solves a little bit the data bottleneck, but still there will always be a connection between who has the real data and who invests in synthetic data in order to have this more information symmetry. I'm closing by saying the following. I mean, those are challenges to arrive to a brighter economic future, but this future is in our hands. It is our decisions to shape the conditions and circumstances under which these substantial benefits of AI can emerge. And the avenue we should explore, what we need to have in mind is we need to minimize AI bottlenecks, especially on skills and data, and eliminate also AI-associated risks that can be serious. I didn't talk about that, but I should give also, I should ring a bell here. Security, privacy, manipulation of human behavior, physical and economic harms are some of the risks that we need to have proper regulation in place to address in a way it is the best way. And a safety net needs to be in place because, surprising, as in any regulation, even in these regulations, not all people will be the winners. There will be winners and losers. We need to help and protect the people who will lose out of this. Thank you very much.
Thank you, Georgios, for that very thought-provoking and stimulating talk, both breadth and depth, which is rare. We have around 15 minutes left for questions from the audience, and I see a few hands up already, so maybe we can take 3 at a time, and then you can respond in turn if you like. Starting over there.
Hello, thank you very much for an interesting lecture. The first thing is just a clarificatory point. You did not point out the names of the journals. Would it be possible to have them at some stage of the references that you put on the live? But leaving that aside, there are so many questions, but the one I wish to concentrate, just one, would be what you were mentioning about the relevant mix of skills. It seems to me that that is the key factor in managing the change and gaining advantages. But this is a huge problem as to how to incentivize, how to keep people, how to retrain people. And then even the definition of AI is nowadays not very clear. It seems like a black box within a black box. Because if you go to programming, you know exactly what you're doing with computer programs and how you can run them, because I myself have written a few early programs for diagnostics of medicines, etc., using computer languages like if then else analysis loops. But when you go to the present day level of AI and generative AI, it becomes so complex that even a professional in computer programming might not know what what AI really means. So I appreciate the complexity of the problem, but whether you have any comments on these issues.
So one more over there, and then another over there. And please also briefly introduce yourself, if that's all right.
Hi, I'm Pedro Llanos. I work here at the Oxford Martin School. So thank you very much for that wonderful presentation. I have a very specific question. If we're really facing a scarcity of AI skills, how come we're seeing declining returns to computer science skills or engineering skills? I'm having some trouble trying to understand that relationship. Maybe it might be the skills mix, as you mentioned, but is it something else there?
Other question over on that hand.
You showed a graph of the progress of synthetic versus real data being used in AI, but it was
Prediction.
the point where we were in the graph was 2021, 2022. So I was interested to know in 2025, where are we on that path of, because it was a rough graph.
Yeah, yeah.
But that was prediction. So how are things transpiring?
Yeah. Okay, I will start with the last question. Thank you. So indeed, that was a prediction based on the state of technological advances back then. Since then, we have seen a tremendous focus on generative AI tools, the tools that generate data. And basically, the way that this synthetic data is from then to now has increased, it's exponential. So it's a little bit more than the prediction. We follow not a concave, but a convex function so far in this prediction of synthetic data. So synthetic data has become a new norm, and we see that it develops very fast out of the generative AI systems. And many corporations do that exactly because they have some restrictions on the data from real world. They have already reached a scale that they say, okay, all real data, work data has been something we considered as an input for the extremely big AI systems. Can we do better than that? And here is where the synthetic data can provide some advances and improve AI algorithms.
Will the synthetic data tend to share, in order to be meaningful, it's based off samples of real world data. Will it share the same means and sort of ranges as the sample data? Do you know what I mean? Like,
yeah. So the way this synthetic data is developed is, first of all, you have an AI system. And in generative AI, this AI system has two neural networks. The one neural network has access to real world data. Let's say how a paper bill looks like. The other neural network has no idea about real world data, and it is asked to reproduce the image of the paper bill. And this is the way generative AI systems are trained. So the neural network that has no access to real data, in the end, after multiple trials and multiple ways to say, no, this is wrong, this is right, this is wrong, it's able to develop something that it is very close to the original. So that means that in a control environment, synthetic data can represent real data with a remarkable accuracy. But when you add many degrees of freedom, because reality has many degrees of freedom and many dimensions, it will be much harder to replicate consistently everything. But so far, we have synthetic data that replicates real data and produces deepfakes to a level in which it's very hard to assess originality. So even if it will not arrive to it will not arrive to be identical with the real world data, it will be very hard for human beings to understand what is fake, what is real, and what is not. So that means that more or less we will have, for the human eyes, it will be the same variety and dimensions for synthetic data. Now, going back to your question, the issue here is that what is the relevant skill set that each point of time is the most valuable one. So, and that is the issue. As technology advances, the mix of the skills are relevant change. So what was relevant in 2010 is not so, the mix today has changed, and therefore the value of having the mix of 2010 skills is not so high as it was in 2010, because now we need a new mix of skills which is more relevant today, it is more valuable. So it's the argument is not the decline of the value of skills, but the decline of the mix of skills I have over time. And this is the important thing we need to realize. Thanks so much for your observation and your question. I will be more careful to also produce, to measure the journals. Some of these papers have been published in top economic journals, the declining of returns to skills QJE, for example. Some others are published in policy bodies, or they are working papers. But I can make sure that in the future edition of this presentation, I will make it clear. Now, on the black box comment, yeah. So it's true that for complicated AI systems, it's very hard to explain fully how they reach from the input, because what people do is they basically take care of the input and they observe the output. So there is the field of explainable AI that targets exactly that, to open this black box and try to give meaning and find a rationale on how output is linked with the input. But I guess in the most of the cases, what people working with this system are interested in is the output and having a metric in place that determines how this output is measured in terms of firms' objective and success. And what they do, exactly because they could not fully understand this modeling, is playing with the weighting functions of the input that it is considered to see whether the performance of the algorithm improves. So I guess there are always ways not to fully escape from this black box case, and this is also interesting because new European regulation in the EU ask firms to explain why these algorithms derive this output. But I guess it's through experimentation, through multiple trials, to get a better idea what are the weighting function over the input that affects somehow the output and how it is developed. But of course, this should be something that requires continuous monitoring. I will give you an example.
One of the points I'm trying to make is, if you are designing an AI course for a university course degree, first you have to think what are these units that constitute a degree, a BSc, say, in AI, because this has been difficult even for computer science, because all over the world, most subjects like mathematics, chemistry, they are very uniform, but computer science, no two universities seems to agree. So that is one problem.
But
and the second,
you can follow another approach here. You can follow the approach of getting inspiration for the frontier applications of AI system, and try to be able to prepare your students and make them understand how in these frontier applications of AI, what is going on and how a person can help for providing such kind of services, such kind of system, how can develop the AI skills. I fully agree, but if we enter to this discussion over the definition, as you said, it's very difficult to find a common agreement. So what I would like to propose is an application-based approach, focus on what we see in the frontier, and based on what we see in the frontier, we can design the curriculum analysis. So case studies could be of great benefit here and can give an inspiration how we can design an educational program much more efficient and close to what market wants.
So time flies, and in the spirit of ending 30 seconds earlier rather than 10 minutes late, I think we should close it at that. And so please do join me in giving Georgios a warm round of applause.